Hello, and welcome to Algebra Unit 3, Concept 3, Lesson 1. Today, scholars will solve quadratic equations using tables and graphs. So we're going from factoring to solving quadratic equations. So, first question is, why are the x-intercepts of the graph of a quadratic function important to the solution? So first of all, we'll make sure you understand the x-intercepts are the points where the graph, well, you can't see that very well, can you? Let's try something you might be able to see. Sort of see that. Where the graph crosses your x-axis, that's your horizontal axis. So this is a graph of x squared minus 16 equals 0. So you can tell if you graph this, the solutions of it are the value or values that make the equation true. We say that they make it true because here our y value is 0. So if we replaced this with y equals x squared minus 16, the point where y is 0 is how we get this. So the x-intercepts of this function occur where it equals 0, and they represent the solutions. In this case, the solutions would be -4 and 4. So how can you use a table to find the solutions of x squared minus 7x plus 6 equals 0? Okay, so you guys are going to be using Desmos. So first of all, we have to rewrite the equation to say y equals. It has to say y, or you can use f of x. It doesn't matter. I used y. And then you're going to set it equal to x squared minus 7x plus 6. After you do that, you're going to select this edit list button. It looks like a little gear. When you click that, it's going to look like this down here. If you have a valid quadratic function here, you'll see this option for a table. You have to click that button, and then you will see the table come up. You'll see they have different x values. You can put more x values in, and it will give you the corresponding outputs. So you can use this, and in this case, the solutions are the points, the x values when y is 0. And you can put in other values to find the other points. So this is how you can use the tables. Again, edit list, press that button to get your table. So now let's look at how we use this in the real world. I know you guys always are interested in that. So Anastasia hits her golf ball off of the tee. The height of the golf ball is modeled by this function. F of x equals -5x squared plus 25x plus 1, where x is the number of seconds after the golf ball is hit. How long is the golf ball in the air? So if you graph this function, it'll look like this. So remember that our x is the seconds in the air. Our y is the altitude. So if you trace it, or you on the Desmos, you can just sort of click near it and it'll show you what the point is. Y equals 0 when x equals 5.04. Obviously, there's another 0 back here, but that's when she hit the ball. So we're looking at the distance between these two zeros. So it's 5.04 seconds that the golf ball is in the air. Okay? And you can actually sort of, looks like the arc. Let's look at a couple more. So Dexter is designing a water feature for his patio. He wants to have a plume of water that arcs over the patio. The water would be captured in a tile basin that's 1.5 feet in diameter. The arc of the water plume is modeled by the function f of x equals -5, oh, that should be an x squared, sorry, plus 3.75x. I left off the square root of that, don't worry about it. So how far from the water source can Dexter place the basin? Okay, so here our x value is the number of feet away it is. The y value is the height. So this is our height, and this is our distance in this case. So we're trying to figure out where we need to place the basin. So we look at this. There's 2 zeros. This is not the 0, 1. That's the distance. That's the starting point for our function. We're going to look at right here. So right there, you can see that we are at about, let's see, that's 5, 6, 7, about 7.5. So it would be 7.5 feet. Because you want the water to be back down at the bottom of the basin. We catch it right there. Not too hard when you're using these graphs. So just a quick review of what we have learned today. A quadratic equation can be written in standard form, which is ax squared plus bx plus c. We've talked about this. It equals 0, where a, the coefficient of our x squared, is not 0. Quadratic equation can have 0, 1, or 2 real solutions. Zeros of the functions related to the quadratic equation are the solutions to the equation. So when we're looking for the zeros, we set y there for the 0. Those zeros of the graph are our solutions. So if we see x squared plus 5x plus 4 equals 0 and we graph it, the solutions are x equals -4 and x equals -1. We can see that down here on the graph. -1, -4. Those are our x-intercepts, and those are our solutions. You can see it on a table by locating the points where y is 0 and x equals -4 and x equals -1. Not too hard. So you're going to work on your Savas assignment and then your mastery check. And I will see you all in class.